So for our second lesson, we're going to add and subtract rational expressions. We have kind of a list of things that we need to look for. First thing we're going to do is factor if necessary. So we're going to have two fractions. That's what our rational means. Expressions just means we don't have an equal sign. So we're going to factor everything if possible, cancel any common factors, and then we're going to look at the denominator. If our denominators are the same, we're going to add or subtract the numerators, the numbers and terms on top, and place the results over the common denominator. If they're different denominators, we have to find the least common denominator and change the expressions so that they have a common denominator. Then we're going to add or subtract them. Again, place a result over the common denominator, reduce if possible, and leave everything in factored form on the denominator. Sounds really terrible. Oh, this one's already on there for us. But here's a couple problems that have been worked through. So question number 1 on the left, we have two rational expressions. They have a common denominator. So when I look at my denominators, they both have x plus 4. So since these both have x plus 4s in them, they have a common denominator. You can just take whatever sign's here and do that to the top. So I'm just adding the x minus 3 and the x minus 2 together. So we kind of swoosh them together into one fraction. Your denominator stays the same. And then all you do is combine like terms. So x plus x gives us this 2x, and negative 3 and negative 2 combine to give you that negative 5. That would be your final answer because nothing simplifies. The trickier one is on the right. We have a subtraction sign here in the middle, but we were given a common denominator. So since we have a common denominator, we can shove them together, but we've got to take this negative and distribute it in. So it's a negative 6x and a negative 1, and then you just combine like terms just like we did on the second one. So one extra step to get rid of that negative or the minus sign in the middle. Your answer is down there at the bottom. Let's try. All right, so here's our first example to do together. So here we have unlike denominators, so the denominators are different. The one way you can always, that will always work, you can multiply both fractions by the opposite denominator. So if I take this denominator, I'm going to multiply 5m, 5m, top and bottom for the first fraction, and then I'm going to do the same thing with the second denominator over here. I'm going to multiply 8n, 8n. So then I want to multiply these together and these together. When you multiply fractions, you multiply straight across. So the tops get multiplied together, the bottoms get multiplied together. So 5m times 3m, 5 times 3 is 15, and m times m is m squared. So that's my numerator for the first fraction. For the second fraction, I'm taking 5m times 8n. Well, 5 times 8 is 40. M times n is just mn. Repeat your process with the second fraction. I'm just bringing that plus sign down. 7 times 8n, 7 times 8 is 56, and the n comes down. For the denominator, 5m times 8n, 5 times 8 is 40, m times n is just mn. Now when I look at my denominators, they're both 40mn. So now I can just add, since this is addition here in the middle, I'm just adding the tops together. So 15m squared plus 56n, all being divided by that common denominator, 40mn. Then I have to reduce if possible. Can I reduce 15, 56, and 40? Nope. Then you have to look at your variables. Do all three terms have the same variables in them? No, so the first one doesn't have an n. Second one doesn't have an m, so we can't reduce. So this does not reduce. This is actually your final answer. let's try this one. So example 4, first thing that stands out to me is that this right here is a quadratic that could easily be factored. So we're going to take that denominator and we're going to factor it. So since this is a quadratic, the first thing I'm doing with it is I'm going to factor it. Yep, factor it in your asterisk. So 1 top left and top right. 3 goes to the bottom middle. And 1 times -4 goes in the top middle. Which gives me factors +4 and -1. So this turns into x plus 4, x minus 1. So we factored this so it looks different. So now when I look at my two rational expressions, I need to figure out what the least common denominator is. Would you agree that both fractions have x plus 4 in them? Yeah. So to get my least common denominator, I got to figure out what's missing in one of them. Well, the first fraction has x minus 1 in it, but the second one does not. So we're going to take the second fraction and we're going to multiply it by what's missing, the x minus 1. Got to multiply top and bottom by x minus 1. So we don't have to do anything to that first fraction, the x minus 3 divided by x plus 4, x minus 1. But I do, however, have to take the second fraction and multiply the denominator. We're not going to actually box them together. We're just going to leave them as your two factors. But for the top, I am going to distribute the 2x into the x minus 1. So 2x times x minus 1 is 2x squared. Minus 1 times 2x is minus 2x. Do you agree that we have a common denominator now? Your denominators are exactly the same in both fractions, which means we can just take these tops, and since it's addition here in the middle, we're going to add them together. When we write them down, we always want to start with the highest exponent. So when I write my first term, I want the 2x squared first. Then I'm going to take x minus 2x to get negative 1x, or just negative x, and then the minus 3. The denominator is still x plus 4 times x minus 1. When I look at this, I notice the top is now another asterisk problem. So to see if I can reduce, I have to factor the top. So when I factor the top, I have 2, negative 1, and be careful, negative 6. Two numbers that multiply to give me negative 6, but add to give me negative 1, negative 3, and positive 2. So we can reduce the 2 and the 2. So I have factors 2x minus 3 and x plus 1. I haven't touched my denominator, so x plus 4, x minus 1. Can I simplify anything? No. So since I can't reduce, you can actually, give me this answer or this answer since it didn't reduce. But you must check to make sure that it doesn't reduce. So anytime you end up with a quadratic in the numerator, you want to factor it to make sure none of the factors cancel for you to reduce. All right, next one here. Again, I see a quadratic on the top, so I know I'm going to have to factor something. I see another quadratic in the bottom that again is going to have to be factored. Oops. Remember how I told you a couple weeks ago that a difference of squares shows up sneakily? So this is a difference of squares, it factors into x plus 3 and x minus 3. Again, you could use your asterisks with that, but it's not necessary. So the first fraction has 2 factors in its denominator. The second one only has 1. Which one's missing? The x minus 3 is missing, so we're going to take and we're going to multiply, the top and the bottom of the second fraction by x minus 3. So that is our least common denominator, x plus 3, x minus 3. Bring your subtraction sign down. Now we have x plus 3 and x minus 3 in the denominator. When you go to multiply the numerator, we have 2 terms times 2 terms. That's either a box problem or a FOIL problem. I'm going to go down here. So x plus 5, x minus 3. So fill out your box. X times x, x squared. 5 times x is 5x. Negative 3 times x is negative 3x. And 5 times negative 3 is negative 15. So when I write my numerator, I'm going to have x squared plus 2x, because it's 5x minus 3x gives me 2x, minus 15. Be very, very careful. This time I have a minus sign here in the middle. The best thing you can do is change that to addition and change all the signs all the way across the top of that next fraction. So this became minus, and this became plus because it was already negative. So we distributed that negative. Now for our next step, we want to go through and combine like terms. We're keeping our common denominator. When you combine like terms, you have 2x squared minus x squared, which is 1x squared, or just x squared. You have no other x terms but the negative 2x, so minus 2x. Then negative 30 plus 15 is negative 15. Unfortunately, the top is another asterisk problem. So you've got x squared. We've got to check to make sure there aren't any common factors in the top and the bottom. So we've got to use our asterisks. So looking at the top, I have 1 top left, top right, negative 2 in the bottom middle, and negative 15 in the top middle. 2 numbers that multiply to give me negative 15, but add to give me negative 2, negative 5, and positive 3. What that really tells me is that the top has factors x minus 5 and x plus 3. The bottom we haven't done anything with, it's still x plus 3, x minus 3. So now that I've factored the top, what do you notice? You can cancel the x plus 3 on the top with the x plus 3 on the bottom, which means that actually, so we reduced. So the x minus 5 is still on top, the x minus 3 is on the bottom. Am I allowed to cancel those x's? No. They're involved with, both of them involved with subtraction. So your final answer actually is x minus 5 divided by x minus 3. Only one answer is correct here because this over here reduced. So on the last problem, it didn't reduce, so you could have written it both ways, but this time it does reduce, so there is an absolute correct answer over here on the right.
Okay, so you said we could cancel the x's because of subtraction. So you can with addition?
No. Not if there's addition or subtraction with the x, you can't cancel it.
Okay.
Unless they're exactly the same. Like here on the step previous, we canceled out the x plus 3s with the x plus 3s, but that's because there's multiplication right here after them and multiplication right here before. Good question. Let's try another one. So looking here, Does anything need factored? Do you have any x squareds or greatest common factors? No. So this time we're going to have to multiply both fractions because this and this make up your least common denominator. So I'm going to have to take the first fraction and multiply it by 5x minus 2, top and bottom. And then I'm going to have to take the second fraction and I'm going to have to multiply it by 2x plus 5 and 2x plus 5. Again, we don't actually multiply out the denominators. We just leave them as two factors. So 5x minus 2 and 2x plus 5. But the tops, we are going to have to multiply them together. I need to take the 3x minus 2 and box it with the 5x minus 2. So I'm going to go over here and make us a box. And we're going to multiply the numerator of the first fraction, 5x minus 2, with 3x minus 2. So 15x squared, negative 6x, negative 10x, and positive 4. All right, so my new numerator is going to be 15x squared minus 16x plus 4. Don't forget the minus sign in the middle. Then for your second fraction, again, the denominators are going to stay the same, 5x minus 2, 2x plus 5. When I look at the top here, I don't have to box because I've just got one term times two terms, which means I can just distribute. So 2 times 2x is 4x, and 2 times 5 is 10. The tricky part is I have a minus sign, which means I need to distribute that negative to the top of the second fraction. Once I get here, I have addition. I'm going to add them together. Keep your denominator the same, 5x minus 2, 2x plus 5. And then combine like terms on the top. So nothing gets put with the 15x squared. Negative 16x minus 4x is negative 20x. And then positive 4 minus 10 is negative 6. Another quadratic on the top, which means I need to factor it. In this case, I have 15 in the top left and top right, negative 20 in the bottom middle. And be careful, we're taking 15 times negative 6 to get the top middle, which is a value of negative 9. If I look at my factor chart, I can see the factors of 90. There are 6 pairs of them. I need to figure out which two, if two, will add together to give me negative 20. So when I look, 1 and 90 definitely can't. 2 and 45 can't. 3 and 30 can't. 5 and 18 close, but not close enough. 6 and 15, no. And then 9 and 10 can't work. So this, you can't factor it using your asterisk, which means it doesn't reduce. So if it doesn't reduce, this back here would be your final answer. So this does not reduce. Questions or concerns about this list?